question is waveform of V naught of t shown in the circuit below is. Here the clock duration is 2 milliseconds, means it attains plus 12 volts first 1 millisecond, and next 1 millisecond it takes minus 12 volts. Okay, so suppose if Vi is equals to plus 12 t in between 0 to 1 millisecond, this is the first cycle, minus 12 volts, it is in between 1 millisecond to 2 millisecond. Similarly, it repeats for 3 to 4, 4 to 5. In that manner, it is going to repeat. So, if Vi equals to plus 12 means the transistor is going to turn on. So, transistor is in on situation. This is 0.1 microfarad. So, V naught is nothing but voltage across the capacitor. So, in the steady state position, the capacitor acts as an open circuit. Means in the steady state position, Vc of t is nothing but 12 divided by 12.1k into 0.1k, which is equals to 0.1 volt. 0.1 volt means 0 to 1 millisecond. The amplitude of the output voltage is 0.1 volt, which is a constant, hence this one. Okay. Now, if Vi is minus 12 volts, then the transistor turns off, means it acts as an open circuit. So the Vc of t is nothing but 12 into 1 minus e power minus t by RC. Here RC is the time constant, that is 12 into 10 power 3 into 0.1 into 10 power minus 6, which is 1.2 milliseconds. Here, but the duration of the input waveform, which is having a minus 12 volts, is only for 1 millisecond, but the time constant is 1.2 milliseconds, means it needs more time to charge towards the minus 12. So after 1 millisecond it's going to attain again plus 12. When plus 12 means the output is going to be 0.1 again, hence the duration of the charging period of the output waveform is only for 1 millisecond, that is 1 to 2 milliseconds, hence output waveform is C. Option C is correct. Two normal communication systems have the same frequency distribution function, but the standard deviation of the first is twice that of the second communication system. What is the maximum frequency of the first communication system to the second? Here, the frequency distribution function f is given as sigma 2 pi e power x minus mu 2 sigma square. So f1 is first communication system, sigma 1 2 pi. It is the maximum. So this is x minus mu by 2 sigma whole square. The f1 attains maximum frequency whenever x equals to mu, that is 1 by 2 pi under root into sigma 1. Similarly, f2 root 2 pi sigma 2. We know that sigma F1 is 2 sigma 2 from the given data itself. So F2 is nothing but root 2 pi. Sigma 2 is nothing but sigma 1 divided by 2, that is 2f1. So f1 by f2 is the frequency ratio, that is 0.5. Hence option B is correct. Consider a joint ensemble xy pxy of a2 comma bz equals to 1 by 12 for z equals to 1 2 3. Then conditional probability, that is p y by x of b3 by a2 is, here b3 a2 is nothing but probability of a2 b3 divided by probability of a2. Here probability of a2 b3 is nothing but 1 by 12. Probability of a2 is nothing but j equals to 1 2 3 a2 bj, which is nothing but 3 into 1 by 12, that is 1 by 4. Hence probability of b3 by a2 1 by 12 into 4, that is 1 by 3. Hence option C is correct. Maximum power transfer to load C is, the value of C we have to find out. Here we know that the load impedance is 2.5 ohms. Okay, which must be equals to 2 plus j xl minus xc, that is 2 plus j of omega l is, omega is 2, so 2 minus j omega c, that is 2c. So it is equals to 4 plus 2 minus 1 by 2c whole square, 2.5. So 6.25 minus 4 equals to 2 minus 2c whole square. So 2 minus 2c is equals to 1.5. So 1 by 2c is nothing but 0.5. C is equals to 1 farad. Hence option A is correct. The probability that A qualifies the test is 2 by 3, and the probability that B qualifies the same test is 3 by 3.